Okay, this is what we've all been waiting for. I'm going to derive 3 of the 6 inverse trig derivatives in this video. I'm not going to derive all 6 in this video because I just don't want to, put so much in one video alone. So in this video, I'm going to derive the derivatives of sine inverse of x, cosine inverse of x, and tangent inverse of x. I am going to derive the cosecant inverse of x, the secant inverse of x, and cotangent inverse of x derivatives in the next video. So this is sort of our part 1 here. Now just a quick FYI here. If I do say, I'm just going to say FYI. If I do say, like, arcsine of x, that's our first derivative that we're going to have here, arcsine of x, just know that that's the same exact thing as sine inverse of x. Okay, so I may use these, I may I may say this at one point, I may say this at one point. These mean the exact same thing, okay? So arcsine of x is the same as sine inverse of x. Okay, so in this case here, when we're going to try to find the derivative of sine inverse of x, we just say y equals sine inverse of x. I'm going to write it in this form. We're not going to use arcsine of x, just because I feel like it's easier to understand when we put it in as sine inverse of x. And the reason why is because, well, let's look at some properties here of functions and their inverses, right? If we have f of f inverse of x, right, the function and the inverse will cancel, and we get x. Same, the converse is also true, right? F inverse of f of x, that must also equal x here, right? So then the inverse and the function cancel. So hopefully you knew this already, right, from your studies of algebra 2, pre-calculus. So hopefully you knew this relationship already. If not, here you go. This is true. Try it with anything. It should work. So with this being said here, if I do the same, if I apply the second property here, or no, not the second property, the first property here, f of f inverse of x, can't I just do sine of both sides, right? Because won't sine and the sine inverse cancel, leaving us just x, right? So shouldn't sine of y equal to x then, right? Like if y equals to sine of x, sine inverse of x, shouldn't sine of y also equal to x? Well, I mean, we use this property, so it must work, right? So, okay, where do we go from here? So, I want to find dy dx, okay? Right, dy dx is the derivative. So, in order to do that, I'm just going to do some implicit differentiation. I'm going to take the derivative with respect to x of both sides. So, if we do this here, I'm going to get cosine of y times dy dx. Remember, chain rule, right? Derivative of sine is cosine. If you do not know how I got that, watch the one of the videos in Understanding Not Memorizing series. I go over how to find the derivative of sine and cosine, and of course, yesterday's video I went over the other trig derivatives. So make sure to watch that if you don't understand how I got that. So I got cosine of y, and then the derivative of the inside, which is dy dx. Then that equals to d dx of x, which is just 1. I want to isolate dy dx here, so I want to divide both sides by cosine of y. Okay, so these will cancel, and we get dy dx equals to 1 over cosine of y. Well, how do we get this cosine of y here? Well, in order to get this cosine of y, now technically this is a correct answer, okay? The derivative of sine inverse of x is 1 over cosine of y, okay? This completely acceptable answer in some cases, okay? But usually dy dx, we want it in terms of x, okay? This is correct, but I wouldn't say, yeah, maybe not. Maybe it's not an acceptable answer, okay? We can still do more. And what I mean by that is, we want to get this in terms of x. So, cosine of y, how do we find that? Well, we want to go back to this relationship here of sine of y equals x. Sine of y equals x. sine of angle y equals to x over 1. Let's draw a triangle. Now, this is what I was talking about when I said it's going to be a visual sort of thing. Okay. Sine of y. That's not 90 degrees, but ignore that. Sine of y, angle y equals to x, opposite of y, right? Opposite. Hypotenuse, watch my right triangle trig if you're confused. Hopefully you're not, because you studied trig already. Opposite. Hypotenuse, opposite 90-degree angle. This should be x. Or no, sorry. This should be x. This should be 1. Now we know that cosine of y is adjacent over hypotenuse. How do we find adjacent of y? Pythagorean theorem. We can call this C, we can call this A, we can call this B. So we can say that x squared plus b squared equals 1 squared. X squared equals to 1 minus b squared. Or no, sorry. The heck did I just do? B squared equals to 1 minus x squared, and b equals to the square root of 1 minus x squared. Okay, let's write that down. Square root of 1 minus x squared. Cosine of y, adjacent to y, is square root of 1 minus x squared. Hypotenuse is 1. Great, we just found cosine of y. So then going back to here, we'll get that therefore dy dx has to equal to 1 over the square root of 1 minus x squared. Okay? So, you guys see how beautiful this proof is? Now, there are other ways to prove this. Keep in mind, but do you see how, like, nice it is? Like, how we actually went back to the core of trigonometry? Right triangle trig? Isn't that just cool? Right? Like, take a step back here. Acknowledge what we just did. We, like, went back to the basics of trig in order to find the inverse trig derivative. I think that's pretty cool. If you don't think that's cool, then I don't know what you're thinking. I don't know who you are. Don't talk to me. Alright? Anyway, let us now do the derivative of cosine inverse of x, or cosine of x, whatever. So I'm going to let y equal to cosine inverse of x. Okay? We want to find dy dx. So using the same property we used here, right? I'm going to circle it right here. Using this exact property here. Taking f of the inverse to cancel both. Right? Cosine. That's not correct way of writing it, but you get what I mean. Cosine. These will cancel. And I get cosine of y equals x. Do derivative of both sides with respect to x. Some implicit differentiation. We get then derivative of cosine. Remember, negative sine of y times derivative of the inside. Again, watch those videos if you don't know how I got these derivatives. Times dy dx equals to the derivative of x, which is just 1. So then we get dy dx equals to 1 over negative sine of y. Okay, so now we want to find negative sine of y. Let's go back to this relationship here, cosine of y equals x. Again, this is technically correct, but you want to get it in terms of x. Okay, so we gotta draw our picture. Okay, and you guys can even do this on your own now. You know, it's the same sort of logic that that we used for the last for finding the derivative of arcsine of x. Okay, it's the same logic, the same process. You can do it to arcsine of x. Okay, so here we have angle y Okay, and again, I'm going to rewrite that relationship here, right? Cosine of y equals x over 1. Opposite of y is x, or no, sorry, not opposite. Adjacent to y is x. Hypotenuse, I'm going to try to make a nice 90 degrees. Come on, careful, careful. But, that's pretty bad. Okay. So then, opposite 90-degree angle, hypotenuse, that's just 1. So Pythagorean theorem, I'm going to say that this is A, this is B, this is C, right? So we can say A squared plus X squared equals 1 squared. I want to solve for A, so we get A squared equals 1 minus X squared. A equals the square root of 1 minus X squared. Okay, so I'm going to write that down, square root of 1 minus X squared. So then negative sine of Y. Well, I'm going to just find sine of y first. So sine of y, right? Sine of y. Sorry if I'm going a little crazy with the colors here. Sine of y, that's just opposite, which is square root of 1 minus x squared over hypotenuse 1. Well, we need to take negative of both sides because we want to find negative sine of y. I'm just going to do times negative 1 times negative 1 of both sides. So then we get negative sine of y equals to negative square root of 1 minus x squared. So, therefore, dy dx equals to 1 over negative square root of 1 minus x squared. Beautiful. Just beautiful. Let's go on to the final one for this video. The derivative of tangent inverse of x. Okay? Please, and by the way, if you get the logic of what we did for finding the derivative of sine inverse of x, you could do the cosine inverse and the tangent inverse. You can keep watching this video if you're like confused still, but hopefully it sort of makes sense. Like, just draw the triangle, do the implicit differentiation, know your trig derivatives, and you're good. That's really how it is. Okay, so I'm gonna let y equal to tangent inverse of x. Do the same logic here, take tangent of both sides, and we get tangent of y equals to x. Okay, so now do some implicit differentiation. dy ddx, and we get, okay, derivative of tangent of x. Remember this, come on, we proved it yesterday, or last video. Because yesterday, you guys may be watching this like 10 years from now. It would be like, yesterday? This video was made 10 years ago. But no, like, you get what I mean, the last video. So this should be secant squared of y times derivative of the inside, our beautiful chain rule. We get dy dx. This then equals to ddx of x, which is 1. Divide by secant squared of y on both sides. And we get dy dx equals to 1 over secant squared of y. Now, going back to this relationship here, tangent of y equals x over 1. Draw our right triangle. Okay, we gotta make the perfect right triangle this time, alright? I gotta make that perfect 90-degree angle, okay? If I mess up, like, I'm gonna hate myself. Okay, come on. Come on, okay. Looking decent. Okay, oh, okay, I can redo that. Let's, come on. Maybe I'm just overthinking it. Damn it. Okay, I hate myself. Alright, I'm not that great with the stylus. So, let us put angle y here. Okay? So, tangent of y, right? That's just opposite over adjacent. This is opposite. This is adjacent. So, adjacent to y is 1. opposite, let me use a green marker here. Adjacent to y is 1. Opposite to y is x. Pythagorean theorem. This is a, this is b, this is c. So we get x squared plus 1 squared equals c squared. Then c has to equal to the square root of x squared plus 1. Okay? C square root of x squared plus 1. So now we want to find secant squared of y. So in order to secant of y, in order to find secant squared of y, I'm going to first find secant of y, and then just square both sides. So remember, secant of y is just the same as hypotenuse over adjacent. Okay? Secant of y, remember, because secant is the reciprocal of cosine, so cosine is adjacent over hypotenuse. Secant of y is just hypotenuse over adjacent. Don't know what I'm talking about? Watch my right triangle trig video. Okay? So secant of y is hypotenuse over adjacent. So then secant of y here will just be square root of x squared plus 1 over adjacent, which is 1. Now we're going to just square both sides, right? Because we want to find secant squared of y. So we'll get secant squared of y equals to x squared plus 1 over 1 squared, which is just 1. Okay? So now we can say, therefore, dy dx equals to 1 over x squared plus 1. Okay, so these are all of our, or these are 3 of these main inverse trig derivatives. Okay, these are the ones that you're probably going to want to, these are the ones that are, I guess, more important, arguably, like the arcsecant, the arccosecant, the arccotangent. You won't use it, I would say, as much as these other inverse trig derivatives in certain applications. So, I mean, it is possible, okay, you may need to use them, but, yeah, these are the main ones. So we're going to go to the other 3 in the next video. So, hopefully you understand, right? Derivative of sine inverse of x is 1 over the square root of 1 minus x squared. Derivative of cosine of x is, or cosine inverse of x is 1 over negative square root of 1 minus x squared. The derivative of tangent of x is just 1 over x squared plus 1. Alright, see you in the next one.